This is Rishi, Jordan, Daniel, Gretch talking to you about distance versus displacement. Distance and displacement are similar, but at the same time different. Distance is the total movement of the position function over the time interval, while displacement is the distance from the starting point at the end of the interval. Now let's talk about distance. Well, distance is used when the total movement over the time interval is desired. There are two ways to find the distance. In normal equations, we have dx equals the integral from a to b of the absolute value of the square root of x dx. In parametrics, dx equals the integral from a to b of the square root of dx over dt squared plus dy over dt squared dt. The magnitude of velocity is speed. And the equation for speed is the square root of dx over dt squared plus dy over dt squared. Displacement is the distance from the starting point. As we can see here, this graph is from 0 to 1. Yes, the distance may be more than 1, but the displacement is only 1 as it's traveling 1 unit.
Displacement can be solved by integrating the velocity in both regular and parametric equations, using the formula position of x is equal to the integral from a to b, velocity of x dx. Distance is greater than or equal to displacement. Distance will always be greater than or equal to displacement. Displacement will only equal distance if velocity is entirely positive, meaning velocity of x is greater than or equal to 0. Total distance is used when magnitude of the change in position or total distance is asked for. Displacement is used when distance from the starting point is asked for. Both distance and displacement are often used in physics. Physics will oftentimes compare two objects to find displacement.
First example we're going to do is when we're given two functions with different velocity functions, one being v of x equals x squared plus 3x plus 2, and the other being x equals x cubed plus 5x, and they're going from the interval 0 to 3, and we're trying to decide which one has a greater displacement. So this is a fairly simple equation, and first you just have to integrate both equations. You go from 0 to 3, and it's x squared plus 3x plus 2 dx. Now you integrate that using the Fundamental Theorem of Calculus, and that will equal x cubed over 3 plus 3 halves x squared plus 2x on the integral of 0 to 3. That ends up equaling 9 plus 27 halves plus 6, which equals 28.5. The second equation is on the same interval, 0 to 3, but this time it's x cubed plus 5x dx. Integrate it again and you get x to the 4th over 4 plus 5 halves x squared from 0 to 3. That gives you 81 over 4 plus 45 over 2, which equals 42.75. And as you can see, the second equation has a much greater displacement because it is approximately 14.25 units further. The equation we're going to do is a parametric equation with dx dt equaling x cubed minus 3 and dy dt equaling x squared plus 4x. And we're trying to find the total distance on the interval 0 is less than or equal to t, which is less than or equal to 1. So this equation requires that we first find the speed of the equation, which the speed, if you remember, is the square root of dx dt squared, which is x cubed minus 3 squared, plus dy dt, x squared plus 4x squared. And it's all the square root of. And then you integrate that equation from 0 to 1. And you can plug this into your calculator and you get 3.8289. Done. Final example we're going to do is you have to find the displacement of the function pt equals x cubed plus 2x plus 3. And it's on the interval from 0 is less than or equal to x, which is less than or equal to 6. So this is the position function it's given, and you have to find the velocity function. So first you find the derivative of pt, which is equal to 3x squared plus 2. And then you integrate that from 0 to 6. Dx, and that will equal x cubed plus 2x from 0 to 6. And that gives us 6 cubed plus 12, which happens to equal 228.
That's all, folks.